Welcome to another episode of Learning. Please like my videos and share them with your friends and colleagues. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Thank you. We continue the discussion of the solutions of the problems from the question paper CSIR National Eligibility Test, July 2025. In this video, we discuss the solution of a problem from the section Ordinary Differential Equations, and the problem is related to Lipschitz Continuity. This question is placed in part C, which is a multiple select question. There can be more than one answer, and the question ID is 562954166. This question is suitable for all these examinations. Right. The given question is, let D be the set consisting of all ordered pairs x comma y belongs to R square such that -1 less than or equal to x less than or equal to 1 and -1 less than or equal to y less than or equal to 1 a square, and f be a map from D to R square with the function defined by f of x comma y is equal to 1 plus under the square root of y suffix plus, where y suffix plus is the maximum of y comma 0. Consider the initial value problem IVP in short. Dy by dx is equal to f of x comma y. Y at 0 is 0. Then which of the following statements are true? We are given four options. Option 1, f is a Lipschitz continuous function on D. Option 2, f is not a Lipschitz continuous function on D. One of them must be true. Option 3, the initial value problem has at least one solution. Option 4, the initial value problem has no solution. So, between 3 and 4, one must be true. Right. Before discussing the solution of the given problem, let us familiarize the concept of Lipschitz continuous function on D. A function f from D, a subset of R power n to R power m, is Lipschitz continuous on D if there exists a constant L greater than or equal to 0 such that norm of fx minus fy less than or equal to L times norm of x minus y for all xy belongs to D. We have noted the following. Any such L is called Lipschitz constant. If such an L exists on the whole of the domain D, then we say f is globally Lipschitz function. If such an L exists only on every compact subset but not globally, then we say that f is locally Lipschitz. Here is a geometric interpretation when f is a function from D subset R square to R square. Then only the geometric interpretation comes. The graph of the Lipschitz function cannot rise or fall faster, than a straight line of slope L. That means we cannot have sharp spikes or vertical cusps. What is the relationship with the other types of discontinuity, the other types of continuities? A function f is Lipschitz continuous implies f is uniformly continuous implies f is continuous. But the converse is not true. That is, here is a counterexample. F of x is equal to root x on the closed and bound interval 0 to 1 is uniformly continuous but not Lipschitz continuous. So here f is a map from D subset of R to R. Right. Now, the bounded derivative implies Lipschitz continuous. This is what exactly we are using. If f belongs to C1, that means all first partial derivatives of f exist and are continuous, and the norm of the gradient, norm of grad f is less than or equal to m on a convex set, then f is Lipschitz continuous on that convex set with Lipschitz constant m. This is very important. This is what exactly we are going to use in this. Right. Importance in differential equations. Here is a Picard-Lindelöf theorem for the initial value problem. Dy by dx is equal to f of x comma y, where y comma 0 is 0. Right. If f is continuous and Lipschitz continuous in y as a rectangle, on a rectangle where this is continuous and Lipschitz continuous in y, on a rectangle containing x naught y naught, then the initial value problem has a unique solution. That means if it is Lipschitz continuous, f is Lipschitz continuous on this rectangle, there is a convex set containing x naught y naught, then the initial value problem has a unique solution. Note, Lipschitz continuous implies the existence of the solution and uniqueness. That means there exists a unique solution. Existence and uniqueness is guaranteed when f is a Lipschitz continuous. If it is just continuous, if f is just continuous alone, no Lipschitz continuous, it's just continuous alone, then there exists a solution by Peano's existence theorem, but not unique. So we are going to make use of this in the question what is given in the examination. Right. Let's get into the question. So the question what we have is this. Yes, we have already noted. Let's get into the solution of it. Let's now discuss the solution of the problem in detail. We have D consisting of those ordered pairs x comma y belongs to R square, minus 1 less than or equal to x less than or equal to 1, and minus 1 less than or equal to y less than or equal to 1. There is a print mistake. It's not x, it's y. It is a square as shown here. whose boundary is included, containing 0, 0 as the center of it. Right. It's clearly a convex set. We are given y subscript plus is defined as maximum of y, 0 is equal to y when y greater than or equal to 0 is 0 when y less than 0. Right. Given the function f from d to r square defined by f of x comma y is equal to 1 plus under the square root of y subscript plus. This is equal to 1 plus root y when y greater than or equal to 0 is equal to 1 when y less than 0. You can very clearly see that this is continuous at y is equal to 0 also. Right, let's call options 1 and 2. Option 1 says f is a Lipschitz continuous function on D. Option 2 says it is not. Right. Now, let's take the partial derivative, dou f by dou y. Dou f by dou y is for 1 plus root y, differentiate partially with respect to y, it is 1 by 2 root y when y greater than or equal to 0. It is 0 when y less than 0. Right. And dou f by dou y is clearly unbounded as y tends to 0 plus. Y tends to 0 plus. Right. Note that dou f by dou y is equal to 1 by 2 root y is unbounded as y tends to 0 plus. That is, the norm of the gradient, that is the norm of the grad f is unbounded on D. Therefore, f is not a Lipschitz continuous function on D. Therefore, the function f of x comma y is not Lipschitz continuous on D. Agreed. So that means option 1 is not true. Option 2 is true because it is not Lipschitz continuous on D. Let's call options 3 and 4. Option 3 says initial value problem has at least one solution. Option 4 says it has no solution. Agreed. Now, note that f is continuous on the rectangle D. Yes. Why? Because y subscript plus is 0 at y is equal to 0. Y is equal to 0. So y is equal to 0, continuity is there, and the remaining is continuous except possibly at y is equal to 0, but it is continuous. If you take the right limit and left limit, they are coincide. Therefore, the initial value problem has at least one solution by the Peano existence theorem. We have already seen it's not Lipschitz continuous. If it is Lipschitz continuous, there exists a unique solution. But it is not Lipschitz continuous, but just continuous on the rectangle D. Therefore, the initial value problem has at least one solution by Peano existence theorem. So, the initial value problem has at least one solution is true. Option 3 is true. Option 4 is false. Thus, option 3 is true and option 4 is not true. Right. Combining all the options, the answer to this question is options 2 and 3. That is the detailed discussion of the solution of the given problem, which is related to ordinary differential equations and based on Lipschitz continuity of a given function. It's definitely an interesting question, and of late, if you see question papers of competitive examinations, questions on Lipschitz constants, Lipschitz continuity, and the existence theorems, involving Lipschitz continuity and all that are coming. So prepare a very good notes, and that will be helpful for you before the examination. Right. I am sure that you have understood the solution of this problem. Thank you for watching this video now. Please like my videos and share them with your friends and colleagues. It is my earnest request to all of you. Please join as a member in my channel and support me and my channel. Yes, this is my channel. Please subscribe my channel if you have not already subscribed. Yes, I am sure I will be meeting all of you once again in another episode of learning. Enjoy learning mathematics. I wish you all the best. Thank you.